first, a bit of a 10-minute kind of recap presentation. So we should all know from the first two presentations what georeferencing is now. But to get the boring slide out of the way first, I just put a 16th definition of what georeferencing is here. So it's the process of assigning location. The process of assigning locations to geographical objects within a certain frame of reference. So in other words, it's the process of taking a digitized image, such as a paper map or a remotely sensed image taken from a plane or a satellite, and giving this real world coordinates within the reference system. Once we do that, as we've seen in a few examples already, we can use this map together with other GIS data. We can overlay it with satellite imagery, modern maps, archaeological data, and many other data sets. Just a random example of this is this 1892 map of Antwerp in Belgium. You can see here it's just a map, kind of with no geographical information attached to it. But once we georeference it, we can then overlay this on a modern map, and we can use this for analysis amongst a modern map. Another example, and I just like this one because it's a GIF that goes on and off, is this 1919 map of Madeira. And you can see again, once we've georeferenced it correctly, we can overlay this on a modern map, and this can be used for analysis and seeing how things have changed. So why do we georeference? So there's many reasons why people georeference maps and images. One common reason is to compare the past with the present. So historic maps, as we've seen already, often show features that no longer exist today. And we can use these to study changes in, for example, human features such as settlements and land use, or natural features such as river systems or coastlines. In archaeology, they can show sites that have since been damaged or destroyed, or they can indicate locations of sites that may currently not be known. Once a map is georeferenced, we can digitize features from it, and we can use these in our analysis. In other words, georeferencing helps us bring valuable information from the past into a modern GIS environment. A quick example of such is we have two georeferenced historic survey of India maps here, one from the 1930s on the left and one from the 1970s in the middle. They've been georeferenced along with the early corona satellite imagery from the 1960s, all showing the same archaeological site. We can then also see on the left a Google Earth image from the same site from 2003 and a Google Earth image from the same site in 2011 and from 2023. And we can use all of these together. We can digitize polygons around the extent of these mounds from all these maps. And then when we look at these together, it's possible to plot the changing size of the archaeological site throughout the time period. So, as Dave said, georeferencing in the MAHSA project. In the MAHSA project, we've used georeferencing extensively. We predominantly use 1 inch to 1 mile survey of India maps from the early 20th century. But as you've seen, we also use 1 inch to 2 mile maps as well. As the 1 inch to 1 mile maps contain a lot of valuable information. So they often show archaeological features such as mounds, old settlements, and other landscape features that may not appear on modern maps. By georeferencing these historic maps, we can combine this information with satellite imagery and other archaeological data sets, as well as using machine learning techniques to identify all potential archaeological features present on the maps. This then allows the landscape to be studied in much greater detail and also helps preserve information that might otherwise be difficult to access or to use. Just a bit of a plug of how we are doing with georeferencing these maps. So this is the current extent of maps that we have and maps that we have georeferenced. So green map shows the ones that we have currently georeferenced, and yellow maps show all the work that we still have to do. And if you'd like to view this online progress map yourself, you can scan this QR code or you can visit the website here. Okay, so now we know what georeferencing is and why it might be useful. Let's take a look at how we actually do this. And these steps are very relevant to the practical session. And this is kind of similar to the small video that Pamela showed earlier. But essentially, there are 4 parts of the georeferencing workflow. So first we load the image that we want to georeference, and we decide on an appropriate output coordinate reference system for this image. Then we add ground control points, which are often called GCPs, which is what I will be calling them throughout this session. It's just a bit quicker. These are matching points that we can identify both on historic maps and on the reference data. After this, we choose some settings such as how we want the map to be transformed, and then we run the georeferencing process. And then finally, we check the results to see how well everything aligns and whether we need to make any changes or re-georeference. Looking at these steps in a bit more detail. So first I said we need to look at the map and decide on a coordinate reference system. I already discussed coordinate references in the last workshop, so I won't go into these, but choosing a CRS is important because it determines where the map sits in the real world and how well it aligns with other data sets. If the wrong CRS is chosen, even a well-georeferenced map can end up in the wrong place. The historic map itself often gives us clues about which CRS was originally used to draw the map. However, the most appropriate CRS also depends on what you want to do with the final map. For example, the Survey of India maps that we're working with, they were originally based on the Everest 1830 datum, but in the MAHSA project, we are georeferencing these into WGS 84. This allows them to align with our database and more modern base maps, such as Google Maps. And the differences are small between the two CRSs, and especially at the scale we're working with. The important thing to remember is that there isn't always one perfect coordinate reference system, and that the best choice is the one that is most appropriate for your map, but also for your project. So after choosing a coordinate reference system, we then need to start finding GCPs. GCPs are probably the most important part of georeferencing. And the step that's really going to decide how accurate your georeference map will be. GCPs are points that we can recognize both on the historic map and on our reference layer. And by selecting these both on the map and the reference layer, we're essentially tying the two data together. So this will become much more clear in the tutorial, but there's essentially 2 ways in which we can assign GCPs to our historic maps. And we will be doing both of these in the tutorial. So number 1 here is by using coordinate values that may already be present on the map. As you can see here in this image, the corner of the map, so this point here, has coordinate values on it. We can use this as a GCP by assigning this corner point the exact values that are written on the map within the correct CRS. The second way of obtaining ground control points is by using feature-based GCPs. This is where we match features that are visible both on the historic map and on an already georeferenced image, such as Google Maps or OpenStreetMap. As you can see in these images here, the 2 red marks are the same location. So you can see on this historic map, this red mark here is this crossroad that still exists today on OpenStreetMap. And similarly with this purple spot, which is a bend in this canal where it splits or joins, is still on OpenStreetMap today. So by tying these 2 locations together, we can confidently say that the historic map should sit in this location. And based on this, you might think that if a map has coordinates printed on it, as in option 1, then these would always be the best choice. However, that's not necessarily true. So historic maps can have small inaccuracies in their grid, and the paper itself may have stretched or shrunk or bent over time. And in our case, in MAHSA, although the Survey of India maps include coordinates, as shown in this image, we found that using good quality feature-based GCPs almost always produces a better alignment with modern imagery. The important thing is to use the method that gives the most reliable result rather than assuming one approach is always better. And as I said, today in our practical, we're going to be using both methods. So as we're going to be using feature-based GCPs, I thought it would be good to give a small example of what is a good GCP to use and what is a bad GCP to use. Because as I said, having good quality GCPs is really the most important step to having a well georeferenced map. So here I've just given 4 examples. There are many more examples of good GCPs, but these are very common ones and probably ones that you will notice during the practical. So the first example of a good GCP is a road junction. And this is obviously road junctions that are still in the same position, and the historic map and the reference image. So here you can see there is a crossroads. And when we look on the satellite image, we can see that this crossroad is still in the same location. So this is a good point to use as a ground control point. The second example is bridges over unchanged infrastructure. The example here I've put is a canal, because often canals don't change location once they're built. So you can see the canal here with a bridge across it, and we can see in this satellite image, we have the same canal with the same bridge across it. Also a good point to hide a historic image for the satellite imagery. Number 3 is a distinctive point of a noticeable building. So this could be, often is a historic building such as a fort or something like this. Here you can see it's clear from the historic map that this is the same edge of the building as we can see in Google Maps. So using the corner point of one of these is also a good GCP. And 4th, I put crossing over a rail track, because in the maps that we're using, there are quite a lot of railway tracks. So similar to number 2, it's quite uncommon for a railway track to move locations. It does happen, but you should be able to see if it has moved locations. So often you will have a crossing over a rail track that is present on a historic map and is still present on modern day satellite imagery. Okay, so what are bad examples for using as a GCP? And these may be things that you'll see in the practical and think, this might be okay to use, but often they are not accurate enough to be used. One example is a natural watercourse. So in general, watercourses like rivers or streams that are natural tend to move and change locations, especially often the maps we're looking at are over 100 years old. Within that 100 years, they will have at least a bit changed location. This is not absolutely always the case, but mostly they are not similar enough to be used for the GCP, as you can see between the historic map and the satellite imagery. The second example I put is unclear boundaries. And by this, I mean what you think might be a boundary for a field or like a land use boundary. As you can see here, you might often think that a boundary that's drawn might fit a forest, and it often sometimes does, but it isn't 100% clear. So if it's not 100% clear, it's something that you shouldn't be using to accurately tie the images together. You should also be careful of using other types of boundaries, such as maybe country borders or state borders, because sometimes these can align, but often they don't. Often borders change at least a bit. The third option of a bad GCP I put here is specific buildings that may have changed. So you can see here that there is a village, and in the modern day imagery, there's a village in the same place. But it's not clear which building we see here is being represented in the satellite imagery. The road layout has changed a bit, and you could possibly guess where the building would have been or which one it is, but you can't be certain. This often happens with villages and towns between historic maps and satellite imagery. And again, if you're guessing and you are, say, 100 meters off, this could make your entire georeference map inaccurate. Finally, I've put here complicated terrain. In some cases, and we've had these cases in MAHSA, you will have to use terrain for GCPs, as sometimes you have maps that are only in mountainous regions. However, it can be tricky and it's not recommended. It can be difficult to exactly match up peaks and ridges because they may have changed, but also because satellite imagery can sometimes not exactly be a bird's eye view. So you may see a peak of a mountain like this one, and you might be able to see the peak of the mountain in the satellite imagery. But often if you use different satellite imagery, so say you use Google Maps and then look on Bing Maps, the image may have been taken at a slightly different angle, and therefore where it looks like the peak in this location in one satellite imagery, it might be over here in another satellite imagery. So we're not exactly sure where this peak may be. So I would stay away from things like that in general. I think the general rule is if you are not sure that it is something, that it is the same thing, don't use it as a GCP, because even a small amount off can affect final georeferencing. And finally, about GCPs, there are a few further things to consider. First, it is important to spread the GCPs across the whole map, as you see here in this left image. If all your points are clustered in one corner, such as the map on the right here, the transformation may work well in that area, but perform badly everywhere else where you don't have GCPs. It's also important to make sure you have enough GCPs. So in the MAHSA project, we generally aim for around a minimum of 20 evenly spaced GCPs for each map. This gives enough points to capture distortions across the map while also keeping the process manageable. But just to reinforce, it is the quality of the GCPs that is more important than simply having a large number. So for example, 20 poor points are usually worse than 10 good points. You may not know when you're putting your GCPs down what are poor quality points, but luckily GISs such as QGIS provide an error value for each GCP. So this error is calculated in relation to all the other points. So if one point has a much larger error than the other, it may indicate that that point has been placed incorrectly. So that's something we will look at in the practical, and you'll be able to see when a point has a good error value or a poor error value. Okay. So once we've chosen all our well-spaced GCPs, we need to tell the GIS how we want the image to be transformed using these GCPs. And we do this by selecting which transformation method we want the GIS to use. So different transformation types allow different amounts of movement in the image. Some transformations can make only relatively small adjustments. For example, here, the first order polynomial transformation. This allows the image to shift, rotate, or change size and stretch slightly to better fit the GCPs. Other transformations allow the image to bend and stretch more. For example, as you can see in the second order polynomial transformation, this allows some bending of the image to improve the fit between the map and the GCPs. While a third order polynomial transformation, which we won't be using, but this allows even greater flexibility. So it really allows the map to mold to fit the GCPs. So in many cases, a simple transformation works very well, especially when working with high quality and accurately drawn maps. The more complex transformations can help when maps are distorted, but they can also introduce unrealistic warping if they are overfitted to the control points. So in general, we want a general, nice, clean transformation rather than really warping the map towards the ground control point. A good rule of thumb to think about is to start with a simple transformation and then only increase the complexity if you think that's needed. And to sum up the technical parts, the three main things we need to think about when georeferencing, and we'll of course go through these in the practical, is first is choosing an appropriate CRF. Second is deciding on GCP points. And third is choosing a transformation type and a resampling method. Okay, and with that in mind, I'll now move on to the practical session. I first go through the steps. I'll try and do that fairly quickly. I think I have about 40 minutes. And then you'll be split into breakout rooms where you'll be given more time to repeat this practical with an instructor. So I would strongly advise to kind of just watch this section rather than try and follow along with what I'm doing, so you know what's happening. So first thing to mention before I start the practical, and Azade's put this in the chat and mentioned it a few times, is the Google Drive link that she has shared has all the folders and the guides in it. So if I look into the Google Drive link, if I look into maps for georeferencing, we can see that there are two folders here. There's South Asia and Africa. So inside this, there are several maps from different regions that you can use yourself for the practical session. So choose one that you are interested in or a region you're interested in. So either South Asia or Africa. And inside the tutorials and exercises, there is this tutorial 2. So GIS Clinic 2. This is the tutorial that I'm going to be using now. So if you haven't downloaded a map and the tutorial, I'd recommend doing that now, and I have about 40 minutes till we start. So hopefully that should be enough time to download it. Okay, so as I said, I'm going to be using tutorial 2, which I have open here. And I'm going to be running through that, and then I advise that you also follow this. Okay, so first thing we need to do is we need to load QGIS. So I'm going to go on this, and I'm going to be using QGIS 3.4.12. This isn't exactly the newest one, but it is quite new. I think there's 3.44 out now. They release QGIS versions so often that I just have a few months older version. But as long as you have, I think, over about version 3.26, then this should be perfect for this practical session. So as we did in the past workshop, we open QGIS and we should be familiar with the layout that we have here. First thing we want to do as we're starting a new project is actually start and save a new project. So first I'm going to project and new to start a new project. And the first thing I'm going to do is going to save that project. So if I go to project and save as, what I've done is I've downloaded the Google Drive folder to my desktop, which I have here. And I've made my own folder in my desktop version of the QGIS, of the Google Drive folder that I've downloaded, which I've called Georeferencing project. What I'm going to do is I'm going to save my project in here. I'm going to save my GCP points, and I'm going to save my georeference maps. It's often good to keep things together for a project and organized, because as I've said before, when you work with GIS, you tend to create quite a lot of files, so it's good to kind of keep them organized. I'll give my project a name that I can remember well, so I would give it Georeferencing project and save. So I have now saved this blank project as my georeferencing project. Step 2 is I want to set the coordinate reference system. And as I said, we are going to be using the coordinate reference system 4326 for the Survey of India maps. However, it is always good to first open the map and have a look at the map to see if there are clues about what CRS the map has been drawn in and which one we should use. So I'm going to do that first, and I'm using this demo map here. Shall I open? Okay, so here's the map that I'm going to be georeferencing. If I zoom into it, I can look for clues of the coordinate reference system that it may have been drawn in. Often, it will say this down kind of in the legend area of the map. We have quite a lot of writing here, and we have quite a lot of items. However, I do know, because I've looked at quite a lot of these maps, it doesn't actually say on the Survey of India maps what coordinate reference system it has been drawn in. So we might need to look for other clues about what is a good coordinate reference system to georeference this into. And if I look into the corner, I can see that we have coordinate values in degrees and minutes. I do know that this was done in Everest 1830, but if I didn't know that, I would be able to see the degrees and minutes and think, well, should at least first georeference this into a coordinate reference system that also uses degrees and minutes. And we know that WGS 84 uses degrees and minutes. So that's what we're first going to be georeferencing the map into. So I will close the map and I will just make sure that my project is in WGS 84. And I will click OK. As it says in the guide, for the Kenya map, if you're going to be using that, you'll be using a different CRS, which is the UTM zone 36 north. So as with last time, to start, you just have a blank map. You can't see where you are. So what I want to do is I want to click on Quick Map Services on the taskbar. And that's something you should, if you went to the last workshop, you should know what this is and you should have this installed. But if you didn't attend the last workshop, this is a plugin that you will need to install via the plugin menu. So you would have to go to Manage and Install Plugins, which is loading, and you would have to search for Quick Map Services and install that. So I have it installed. So on my toolbar, I'll click on Quick Map Services, and I'm going to use a Google. I'm going to put on two maps actually. I'm going to use Google Satellite, and I'm also going to include Google Hybrid as well, just in case I want to see place names. And what often happens is if you don't have anything loaded, when you first load a base map, it will change your CRS to that to the CRS of that base map. So it changes one to a different version of WGS 84 to the Sido Mercator. I'm just going to change that back to 4326 because that's what we want to georeference in. Okay, now we have a base map loaded. The next thing we want to do is to load our map that we want to georeference into the Georeferencer panel. So to open the Georeferencer panel, we will go to the layer options in the taskbar and click on Georeferencer. If you're using an older version of QGIS, the Georeferencer option used to be in the raster section, but hopefully everyone's got a newer version and you can access this through the layer panel. So if I click on Georeferencer, it usually will bring the Georeferencer panel up in kind of free floating form here. So I can move this around on top of my main QGIS window. We have found that this is not so useful to have this free floating. So what I'd recommend first is to go into the settings section and go to configure Georeferencer. And this is where you have all the settings about the Georeferencer that you can change. And down here, there's an option here that says show Georeferencer window dock. So I'm going to tick this and click OK. And what this does is it docks this free floating window within your main QGIS window. If you click on this, it may put it in the bottom or the left of the screen, but I would prefer this in the right of the screen. There's an image of a good setup of this in the guide. But if you left click and hold the left click on the Georeferencer pane, you can move this around to different parts of QGIS. So I can drag it to the top, I can drag it to the bottom, but we found that it's easiest to have this on the right. So if I'm still holding the left click, and then if I have it so it highlights the side I want it as blue and let go of the left click, we can see that it drops the Georeference panel here on the right-hand side. And this is useful because we have on the left our map image, our satellite image, and on the right, we will have our georeferencing image. And this is good because we can see both images side by side. So now we've opened georeferencing panel and docked the georeferencing window. I will quickly just mention that the georeferencing plugin has its own kind of individual settings that are separate to the main QGIS. So it has its own file and edit kind of options and its own set of icons. And these do various things within the georeferencing window, such as opening a raster image, opening a vector image, starting the georeferencing, loading georeference GCP points, and things like that. And as I go through doing the georeferencing, we will use quite a lot of these buttons. But we know that our image that we want to georeference is a raster image, and it's not a vector image. So first, what we're going to do is we're going to open this image within the georeferencer. So if I left click on Open Raster, this will take me to my folder, and I will just have to find the image that I want to georeference. So as I said earlier, I made this folder called Georeferencing Project. So this is, I know this has all the things that I want to use in this practical session in it, including the map that I want to georeference. So if I find that map, left click on it and click open, it should then, it should then open that map in the right-hand window. So now we have our GIS satellite view on the left and our ungeoreferenced map in the georeferencing panel. In the presentation, I talked about two ways of creating GCPs. So the first one is by using coordinate points, and the second is by using feature-based GCPs. We ultimately want to use feature-based GCPs because this is the most accurate way of georeferencing. But first, to do this, we want to first position our historic map roughly on the satellite image. And when we do this, we can roughly see where it should be, and that will help us find good ground control points between the map and the satellite image. So that's what I'm going to do first, which is section 2 of the guide. So section 1 was setting it up, as we have a good setup here. And section 2 is georeferencing using the corner coordinates. So first, I want to tell the georeferencer how we want to transform the image once we've given it GCPs. So I click on settings here and open transformation setting. And you get this pop-up window, which has several options in it. On page 8 of the guide, there is an image of exactly how you want this set up when georeferencing using corner coordinates. But I'll just quickly run through this. So the transformation type we want is polynomial 1. So in the presentation I did, this was the most basic type of transformation type. So it allows the image to be rotated, to be sized, and a bit of distortion, but not too much bending. And that is because we know the map is well drawn. We know it doesn't need to be bent that much initially just to place it onto our satellite imagery. So we'll choose polynomial 1, and then we'll choose the target coordinate reference system. So as we discussed, we want in WGIS84, which is EPSG 4326. We then want to choose where we want the output file to go. And I want this to go in the folder that I talked about that I made called Georeferencing Project. And it automatically gives the output name of the file to be the name of the map, and then on the end, underscore modified. So you can leave it like that, but I like adding, instead of modified, underscore corners. And this is just so in the future, if you're doing this for a lot of maps, you may come back to the files you've created. You want to know straight away, how has this been georeferenced? And I know this one, if I put underscore corners, this means I know I've georeferenced it just using the coordinate point. So I'll put that underscore corners and click save. Resampling method, we want that as nearest neighbor. I didn't go through this, but just we want to leave this as nearest neighbor because this preserves the drawing of the map. I don't want any compression, but what I do want to do here is there's an option at the bottom, which is called save GCP points. This will usually not be ticked straight away, so you need to tick this option. And what this does is this saves a file that holds your ground control points. This is really useful in case of things like QGIS crashing, which is not unheard of. or in the future, you may want to reload the ground control points so you know how you have georeferenced that map. So I always want to save the GCP points. So I'll click OK, and we have now set up the settings in our georeferencer. So now what we want to do is we want to add corner points. To do this, there is an option here that I actually already have ticked, which is called Add GCP Point. It looks like this, but I have seen in the guide that on the newer version, the slightly newer version of QGIS, the option actually looks like this. It still has the same kind of yellow symbol in the corner. But if you hover over the buttons, you should see what they are. So this is add ground control points. Okay, so with that clicked, my cursor will change into a cross. And then I want to select on the map where I'm going to add a ground control point. So first, I'm going to zoom into the corners because this is where I know the corner coordinate points are. And I'm using the scroll wheel of my mouse to do this. But if you don't have a scroll wheel or something like that, there are some options here to zoom in, zoom out, and pan around the map. So first, I'm going to find this exact corner point that I know is 7130 and 2945 in longitude and latitude. And I'll left click here in the corner. And what happens is you get this box come up. And this is where you can enter the map coordinates if you like, or you can choose the point from the map. As we know the value of the corner coordinate points, we can enter these. So what I'm going to do is I'm going to, in the X or the Eastings box, I'm going to type 71 and space 30. And the reason for that is you can see here that if your coordinate points are in degrees, minutes, seconds, which mine are, degrees and minutes, you enter degree, space, minute, space, second. So I've put 71 for the degrees, space, 30 for the minutes. If your map has decimal degrees, which I don't think any of the maps we've given do, you put it in a different format. But for now, we're just going to use this first format. So 7130 and then 2945. It's important to make sure that we know that point is going to be in WGS 84. If you select a different coordinate reference system, this will georeference it in a different place. So I'm going to click OK. Once I've clicked OK, we can see that the point 0 is added to my georeference map. It is also added to the satellite image, which is those same coordinates on the satellite image. And also in the GCP table at the bottom, we can see that it has now added a point, which is ID 0, which is this point. From this, we can see which pixels from the map it is on, and also the destination. So we can see that this destination in decimal degrees is 7150 and 2975. These are slightly different values to what we see here, and that's because it converts the degrees, minutes, seconds to decimal degrees. There are 3 other options here, but these say NA at the moment, and that's because I haven't added enough GCPs to show an error. So I'm now going to add the remaining 3. We'll do the same to each corner. So I'll add 7145 and 2945. Click OK. That's added a second point, which is called number 1 on the historic map, on the base map, and in the GCP table. I'll zoom out and I'll go into the bottom right corner. I'll click in the corner and I'll add 71, 45, 59, 50. And click OK. And you can kind of see that this is building up the same shape on the base map as I have on my historic map. And then finally, I will go to the 4th point and 71, 30 and 29, 30. A really common mistake that you may do and that we do all the time is typing the wrong coordinates in the wrong X and Y box. So If you do this and it doesn't look right, it is often because either you've put in the wrong value here, or you've put 2930 in the top box and 7130 in the bottom box. So this is a useful thing to check. If everything doesn't look okay when you do this, that is usually the reason. So I click OK, and we can see that the 4 points are on our map. And we can now see that we have the 4 points in our GCP table. Now I have 4 points. You can see that the residual value at the end has been created. And what this shows, it shows the error in pixels of the GCPs that I have chosen. And at the bottom here, you can see it says a mean error value. So this is a calculation of the error value of all the points together. So I mentioned in the presentation that the error will show per pixel, and this can help to highlight whether there is one pixel that's in completely the wrong place. So here you can see that all my pixels have the same error value of 0.62 62 pixels, which is really good. We want to try and keep these under 30 when we're doing this. So if you see anything that's 30 or over, that is where you might need to redo the ground control point. Okay, so this all looks good. I now know where this map's going to save. I've chosen my 4 corner GCPs. Everything looks okay. So now what I want to do is I want to click Start Georeferencing. So I click there, and the georeference should take between 10 seconds and a minute. And then we can see that my map now appears on top of my base map. So the next step is you want to have a look to see how well does this compare. And there's a few ways to do this that are really useful. First way is you can change the transparency of the new file that has just opened up. So to do that, I right click and go to Properties of the Georeference Corners map in my Layers panel, and I will go to the transparency setting in the layer property. I move this down to, let's say, like 60, close enough, 59.7. I click Apply and click OK. And what this does is this makes my corner georeference map slightly transparent. And with this transparency, I can see features on the historic map that are still there today on the satellite base map. And one of the ones that instantly jump out are these 2 train lines. And I can see that on the historic map, you can then see it continues off onto the base map. And this tells me that it is basically georeferenced in the correct general location. I can then turn off and on this map, zoom into some locations, turn this off and on, and I can see that it is in a very similar location, in a good location. Another way to compare the two is by using a thing called the map swipe tool that some people like to use. I like this a bit less, but you may like the idea of it. So it's something that you need to install as a plugin. And it says how to do this in the guide. So if you click on plugins, go to manage and install plugins, plugin window will open, and then you'll search for the name map swipe. And you can see map swipe tool. I already have this installed, but you might not have it installed. So you'd click on this, and there should be a button here saying install plugin. Once it's installed, you will see the logo in your toolbar. So here it is. If I hover over this one called map swipe, and it has a little picture of you kind of swiping the map from left to right. So if I click on this, and I think I need to turn off my georeference map, and then I left click, and then I left click on the map. So you have to enable the map swipe tool, turn off your newly created layer, and then left click and hold on the base map. You can swipe this map on and off. You can swipe this left to right, or you can swipe this up and down. And this is quite useful if you want to zoom in and you want to see how this train line is aligned for the base map and the historic map, or things like that. You may want to zoom into a small village, and you can swipe on off, and you can see how that village has expanded from the historic map to the satellite image. We did yesterday do a bit of an experimentation with this, and it sometimes works slightly different on slightly varying versions of QGIS. So I think on the newest version, you should not have this turned off. But this is something you will want to play around with to see how it works best for your version of QGIS. So I'm going to turn this off and turn back on my corner georeference map. Okay, so that is the corner georeferencing complete. If I zoom in, and you may have seen it then, and I look at something like this railway track, and then I flick between, we can see it's generally in the right place. However, it's not exactly in the right place. You can see the railway track on the historic map is here, and the railway track on the base map is here. You might think that this is really accurate, and it is quite accurate. But if we're doing things like finding mounds or finding archaeological sites, we really want to know the exact location that they're in. And this is, I would say, if I just got the measuring tool here, this is about 50, 60 meters away. And I'm probably guessing that other parts of the map, it is slightly more than that. You can see the same with the road here. It's in a slightly different location to the road on the base map. So what we want to do is we want to get that as accurate as possible. And that's where we need to georeference by feature-based GCPs, which is section 3 of the guide. So first, what's useful is now we've done this, I'm going to save the project again. It's always good to save the project every now and then. So I'll click on Save Project, and you can see the star on the top disappears. That means that the project has been saved. And we also want to save our GCPs. And it should be that when I georeference, I've selected it to save a GCP file. And if I go to my folder, it has done that. So this is my original map, the ungeoreferenced map. This is my georeferenced map, so the one with underscore cornered. And this, which is a dot points file, this is my GCP points. And just to say, this point file is linked to the original ungeoreferenced map. So it will save in the same location as where your ungeoreferenced map is. So if you've chosen your georeferenced corner map to save in a different folder, the GCP file will be where your ungeoreferenced map is. And that happens quite often. We think you've lost the point file, but it's actually just in a slightly different folder. So this is automatically saved. But if we hadn't automatically saved it, I just want to show you a way of saving the GCP file. So you can go to File here, and you can click Save GCP Points As. So I would do this if I'm halfway through georeferencing and then I decide I want to go for lunch or something like that. I can save the GCP point file, and I know that it won't lose my data. In the guide, there's a section about closing QGIS and reopening it. I won't close it and reopening it, but that's page 15. So if you did want to stop halfway through, close QGIS and reopen it, there are some steps that you can follow on page 15 of that. Essentially, you would reopen QGIS, open your project, go to the georeference panel again, open your raster, and then go to File and Load GCP points. And this is where you can load the GCP point file that created. If I click Open, you can see that's loaded it. I already had it loaded, but that's what it would look like. Okay, so now I want to georeference my map based on feature-based GCPs. which is page 16 in the guide. On this page, there's a bit, I'll just put it up on the screen. There's a part here about what makes a good GCP, and this is similar to what I discussed in my presentation. There are things here like intersections of curves of canals, railway road tracks, bridges over canals, temples, places of worship, things like that. The more you georeference, the more you will kind of understand what is a good GCP point and what is not a good GCP point. But as I said in the presentation, if you're not sure about something, don't use it as a ground control point. You kind of have to be sure that that is the same location. Okay, so when georeferencing by feature-based ground control points, you will need to use a different transformation type. And that is because we want to allow a bit of bend in the map. This can be useful because you can actually see in this map, when it's been scanned in, it has a fold through the middle of the map. So it hasn't been scanned completely flat. So we want to allow some movement when georeferencing this map. So first, what we want to do is we want to change the transformation settings. So I go to settings, click on transformation settings. We want to change the transformation type. So if I click this drop down here, I will change polynomial 1 to be polynomial 2. We want to give it some movement, not a huge amount of movement, but polynomial 2 is a good option to use. I will keep the target coordinate reference system as the same, and the resampling method is the same, and also I will keep save GCP points. But in my output file that I want to create after I've found the ground control points, I will open up here and I want to change the name from corners. I'm going to change it to GeoRef. So what that means is when I've finished this process, I would have 3 maps. I'd have the original ungeoreferenced map. I'll have the map that I've georeferenced by the corner points that is called _corners. And then I'll have the map that I've georeferenced, the most accurate map, by feature-based GCPs. I'll click save, and then I click OK. So now the georeferencer is set up as I would like this. So we still have the corner points here. And what I want to do is I want to disable these because I don't want the QGIS to use these points anymore in my georeferencing. So if I untick these, you can see that they slowly disappear. They're still in the table, but I'm just not going to use them. And as it says on page 18, first I need to find 6 ground control points from features that are on my map, and on the base map, on the map canvas. In order to do this, the best method is to zoom in to the corners map that you've georeferenced and find one of these infrastructure or something that is still visible. So as we talked about, this might be a canal, this might be a railroad track, this might be a road or something like this. And then you can kind of either flick on and off the map, see how well things align. So for example, here I have I found a railway track and I've also found a canal that goes through this. If I turn off and on the map, I can see that this railway track and this canal still exist on the satellite image, but they're not aligned that well. So this is a good point to use as a GCP. So when I found this point, I want to go to my georeferencing panel and make sure the Add GCP point is selected. I then want to zoom in on my raw image here to find this location. I may have lost it. Okay, so it's here. So I'm going to zoom in on this, and that was the location I was looking at here. So I can see the railway track and I can see the canal. So if I click on the intersection, so pretty much exactly where they cross, I left click. And what that does is that brings up the Enter Maps coordinates box again. But this time, instead of entering the coordinates, I want to select this place from the map canvas. So I'll click from map canvas. And what that does is that changes this to a cross, and it means I can now click on my map canvas to tie these two locations together. So I'll turn off the corners map, and I will click in exactly the same place, but on the satellite image. So I'll find the railway track again and the canal, and where they cross, right in the center, I'm going to left click. And what that does is that enters the exact coordinate of that location in this box. I then click OK, and then I can turn this back on. And we can see that a new GCP point, number 4, has been created between this location on my historic map and this location on the satellite image. With the transformation type polynomial 2, you need at least 6 points for it to be able to work. So as you can see here, it says NA. That's because there isn't 6 points. So first thing I'm going to do is I'm going to quickly find 6 points. And I kind of want these to be spread out around the map. So I'm going to look at this railway track, and I can again see that there's a canal there. If I flick on and off the map, I can see again that this still exists. So we can see the canal here. You can see there's a branch off the canal and the railway track. If I flick off the corner point, and just as a reminder, we are using the corner point here as basically a guide to help us find the ground control points. I can see that all that infrastructure still exists. So the canal is here, the offshoot from the canal is here, and the railway track is there. So I'm going to use, again, the intersection, the crossing of the railway track over the canal as the ground control point. So I will click roughly in the center of the two, at the left click. I will click from map canvas, and then I will click again the center of the intersection between the railway track and the canal. Click that, it enters the coordinates, and then I click OK, and we can see it's made a new ground control point. Okay, and I'll put that back on again. And I'm now going to try and find a point, let's say down here again, because I know there's a railway track here. There might be a good location for a ground control point. But so there's nothing particularly clear that I can see here. So we can see there was a canal crossing the railway track, but that doesn't exist anymore. So I can't really guess exactly where that would have crossed. So I can't use that as the ground control point. I do see here that there's a black line of a road crossing the railway track, and it looks like there's still a road in the same location. But that is probably something I can use as a ground control point. So that's what I'm going to use. Again, once you've put in enough ground control points, you'll be able to see the error values and you'll be able to see, is that a good one to use? Or maybe I should get rid of that and choose another one. But for now, I'm going to use this. So where the road crosses the railway track, I will left click. Then from map canvas, turn this off and find the same location here and click OK. Okay, and ground control point number 6 has been made. We've got 4 turned off, so we only have 3. I wanted to find 6. Let's see. Okay, so I can now see this part of railway track. You can also see there's the blue canal here. If I turn off the map, I can still see the railway track and I can still see the canal in the exact same shape here. Again, they're slightly not fully aligned. So that is a good place to use the ground control point. I find this on my historic map, and I think I will use the crossing. It's in pretty much the same location. Of course, it's changed ever so slightly, but I think it's good to use. So I'll find where now crosses, left click, click from map canvas, and then I will go and find the crosses there and click OK. So now I have 4. Just need to find 2 more. Okay, here's one where I can see the canal here, and I can see that there's a red road there. And it looks like the road is still in the same location of where the bridge is. So that bridge is also good to use. I've chosen the map here that there's lots of canals and lots of bridges, but often you will not have this many canals, this many bridges. Yeah, left click here on the canvas, and I'll find the exact same point, the bridge where it crosses, and click OK. That's 5 points. And I will find, so I'll find one more. That gives me 6. If I look in this corner. Also, I can also see that the railway track, the road, and the canal are on the historic map and also still there. So what I'm going to use this time is, I think I will use this intersection here because this is clearly the same intersection. Except that is the road and not the canal. So maybe I won't use that. I'm not 100% sure exactly where it is because the canal seems to have disappeared from here. But this looks better. So I can use the canal and I can use the road, the bridge over the canal here that still exists. So finally, I will zoom out and I will find that location, which is here. That's it. Yeah, and I'll click on the bridge that crosses the canal, left click, then click from map canvas. Then on my satellite image, I'll find the exact same location, click OK, and that's given me 6 points. Okay, so now I have 6 points, spread evenly throughout the map. I've turned off the corner 4. There's 2 things that appear. One is that you can see now that the error value has appeared, and slightly unbelievably, the error value for those 6 points is all 0.000. That doesn't always happen. But what you can see is that there is a larger error point for the 4 corner pixels that I've turned off. And this is a way of showing that actually those corner pixels are not perfectly aligned with where the map should be. So at the moment it's a 0 error, which is great. There's another thing you can now do when you have enough GCPs selected, and that is you can sync together the map window, map canvas, and the georeference window. And that is useful because at the moment I have to zoom in and out on both of them individually. But if I click these 2 buttons here, which is link georeferencer to QGIS, and I click the other one as well, which is link GIS georeferencer. Now it should, if I zoom in one, it should also zoom in to the other. And this makes it easier when we're trying to add a GCP because it zooms into the location where we want to add that GCP. You can still turn this off and add the ground control point. And it also works if you zoom in and out of the map canvas. So after this, and I'm not going to do this because we would be here for a while, is we want you to add a further 14 ground control points. So that would give you 20 ground control points in total. And as I said, it's best to have these spread out throughout the map. So not all just in one corner. I've tried to make these 6 kind of spread out throughout the map. But when you have 20, you can really cover the whole area of the map. One thing to say about the error, and I know this kind of gets quite a lot of people when they first start georeferencing, is the error points are all calculated based on the other points. So because of that, the more ground control points you put, the higher the error is gradually going to go. And that is fine. It's fine to have some error. But what happens if you put a ground control point in completely the wrong location? So I'll just quickly do that as an example here. Say I want to put one there, and then from map canvas, I put it here. And I know that's the wrong location. Click OK. All the error values fly up, and it is clear from this that the highest one, 42, is the error I just added. It's the ground control point I just added. So you will, when you do this yourself, you will understand this a bit better, what it shows. But what this is showing is that this individual point that I've just added probably in the wrong place. If I turn it off, they go back down to 0. So what that would show me is, oops, I've added it in the wrong place. I don't want that anymore. And I can right click on it and I can click to remove. And that will remove that ground control point. This does explain this in page 21 of the guide, which is checking residual values and removing poor points. Sometimes, no, so when you found your 20 points, you will then want to click Start Georeferencing, and this will georeference your map based on these new ground control points. But to add, because QGIS does crash quite often, it's very useful to occasionally save your ground control points. So I've added 6. I want to save them. I will go to File, Save Ground Control Points as. Actually already have that from the 4 corner coordinate points. So I think I will call it something else. I will call it demo the feature-based GCP, and then click save. And that means the ground control points are saved. So if QGIS crashes or your computer turns off for no reason, you can always reload these. And I've had, colleagues have had this as well, where you get to about 19 ground control points and you've decided not to save it for some reason, and then QGIS crashes and you lose like an hour of work, and it's really frustrating. So I'd say save these ground control points as often as you can. So I'm going to demonstrate this with 6, but again, we'd like you to do 20. You can then click Start Georeferencing. So I'm using just these 6 points that I've added. I'm not using the corner coordinate points, just these 6 to georeference. So I'm going to click Start Georeferencing and use these points to georeference my map. And it'll add this map that I called _georeference, which you can probably remember earlier from the settings. It add this to my base map. And this will be in a slightly different location, a slightly more accurate location than your original corners map. So I'm going to turn off the corners map. I'm going to open properties and I put the transparency down to 60, click apply, click OK. And it should be, hopefully, if I zoom in, I can now see that the train line is in a much more accurate location. So it actually fits directly above the train line in the Google Maps. If I add the corners, you can see that it's in a different location. And if you add 20 GCP points, this should make all areas of the map very, very accurate. And this is really useful for analysis. This is useful for next steps. So in another workshop or later where you may want to digitize historic features from these maps and then maybe go and look at them on the ground. This is very useful to have it as accurate as possible. And that, I think, is it. So that will be the 3 sections that we want you to do. So set up, then georeference by the corner points, and then georeference by feature-based GCP. Great. Yeah, I think that's it.
Thanks very much, Jack. Yes, exactly. That's it.